In this video, we take a look at how to create stunning fire effects and control their dynamic simulation area. These techniques can be applied to various projects. Let's dive in and get started. To draw the pattern, first we need an image sequence of our pattern forming. If you are familiar with programs like Resolve, After Effects and Premiere, you can easily create that kind of a pattern and export it as an image sequence. Or you can create that inside Blender using geometry nodes and dynamic paint. You can use curves to model your shape. But unfortunately, curves do not have the dynamic paint option. So you have to convert your curve into a mesh and then convert it back to curves inside geometry nodes, or make your entire shape inside geometry nodes using curve primitives. After you make your curve shape pattern, add a curve to mesh node and plug a curve circle into the profile curve socket. Adjust its radius. Then add a trim curve node before every curve to mesh node and use its start and end values to trim the curve. You can do a lot more to your pattern inside geometry nodes, but this is basically what we need for this tutorial. After that, I animate the start and end values of every curve shape and create a pattern drawing animation like this. To create an image sequence out of this, put it into a new collection and call it brush. Add a plane object and scale it to fit the pattern size. Apply the scale. This will be our canvas. In the Physics tab, add Dynamic Paint. Select Canvas type and add Canvas. Do the same for our shape, but select Brush type and add it as a brush. Change the paint color to white. Select the canvas and change the format to an image sequence. A resolution of 512 is enough for our effect. Select animation start and end frame. Add substeps of 1. Select our brush collection. Set the initial color to black and choose the output location, mapping to UV map, and bake our dynamic paint image sequence. And here is our sequence. Now inside a new project, I create a plane, scale it up a bit and call it emitter. This will be our fire emitting mesh. Now to create the smoke scene, go to Object, Quick Effects, Quick Smoke. This will give us this box with domain fluid type and turn our emitter to flow type. Basically, our plane will be the fire emission surface and this domain will control all its settings. Now in the edit mode, I adjust the domain size to fit the maximum area where our simulation going to be. We don't need any unnecessary calculations. Then in the emitter object, I change the flow type to fire and smoke. Since I have to go back and forth between domain and fluid settings, I create another window here and change it to properties. Select our domain. Go to Physics tab and pin this window. Then select our emitter and pin its window. This way I can easily adjust both settings at once without cycling between objects. Let's import our image sequence. For that we need to create a new texture. Just for now, unpin this window. Go to Texture Properties and create a new texture. I call it Fire Map. Make sure the texture type is set to image or movie and then open our image sequence. I check this auto refresh option. Now back in our emitter object physics settings, I enable this texture option and select our texture and UV map. If you don't see anything in the viewport, just change some settings in the domain. Go back and forth to edit mode. Just make some tweaks. That will update the smoke scene to use the texture sequence. And you can see it is working. By the way, this small cube in the domain is a visual representation of this resolution number. Now it is all about adjusting smoke simulation settings. For starters, I enable adaptive domain. This will make our domain adjust its size depending on the smoke scene, giving us much faster results. Set the density to 2. To dissolve our smoke after a little bit of time, I enable this dissolve option and set it to 3. That way we can also see our pattern clearly. Under fire settings, I increase the reaction speed to 1 and the flame smoke to 1.5. Enable noise and set its scale to 1. You can always increase the resolution for a better simulation. To view the simulation in real time, we can do a viewport render. In the output tab, set the resolution to something like 50%. Format to FFmpeg video and this encoding to MPEG-4. Set the output quality to high quality. Choose a location and name for the output file. Now pick a good view of the simulation and go to View, Viewport Render Animation. To view the rendered animation, go to Render, View Animation. To make the fire simulation go outwards from the center, I add a force field force. Set the strength to 0 and the noise to 2. I set this set direction to positive Z. After you are happy with the settings, you can bake the simulation. Go to Cache, pick your simulation frame range and set the type to all. Pick a location and hit Bake All. Let's create our fire material. I am going for a bit fantasy fire look. In cycles, I set the world color to black. Select our domain. It already has a material with a principal volume node. To see the flames, you can just increase this black body value to a higher number like 100. Add volume info node and plug these different outputs into volume socket to see those data. We're going to use these to create our effect. I multiply flame and density outputs using a math node. To increase its strength, I multiplied it again, this time with a higher value like 50. Plug that to emission strength. Set the black body back to 0. Use flame info with a color ramp to create a gradient like this. To add some colors to it, I again use a color ramp and change these sliders to have these pinkish purple colors. I also changed the color of the smoke. That's all for our fire dropping effect. Let's see how to control the emission with an empty. First, free the bake. Since I am using vertex group to achieve this effect, we need to subdivide our emitter plane first. Create a new vertex group. Select all our vertices and assign them to the vertex group. Now add a vertex weight proximity modifier to the emitter object. Put it before our fluid modifier, which was created by fluid physics. Select the vertex group. For the target, I add an empty sphere and select it as the target object. Go to weight pane mode. Change this proximity mode to geometry. Immediately, you can see our vertex group is getting affected by this. We can change these lowest and highest values and empty's location to eliminate a vertex range from the vertex group. To make this work with our fire simulation, in our emitter object physics settings, select the vertex group we created from here. And we see nothing. Because when you free your bake, make sure to set its cache type back to replay. Now, when you start the simulation, you can see it is eliminating that area from the simulation. To make this process much easier, I am going to link our empty's scale to the highest and lowest value. That way I can control the emission area by just changing the location and scale of the empty. For that, I right click on this highest value, add driver and select transform channel from here. Select our empty object and set the type to X scale. What this does is it looks at our empty's X scale and assign it to a variable called var. And then we can use that var value to make changes to our highest value from here. Since I want the X scale of the empty to be the highest value, I leave only var here. Do the same for the lowest value as well, but this time I subtract just a small value. Now you can see these highest and lowest values adjust according to empty's scale. This way you can animate the empty's location and scale and use it to eliminate certain parts of the simulation, or vice versa to reveal a simulation. So that's it. That's how we created this fire simulation effect. If you like to see how I achieve these effects from start to finish, head over to my Patreon page and join our small community. Also, don't forget to check our latest procedural assets pack, Engine Effects. Hit that like button, comment your thoughts below, and don't forget to subscribe to HelloFX Learn. And we will see you in the next one.